etc. So I was very much a hands-on person. In that journey, I started to notice some very interesting, very interesting similarities. As a mechanical engineer, we studied how the shock absorbers work in a motor car, which have a spring, a mass, and a damper. When I do electronics for radio tune circuits, I saw we have a capacitor, inductor, and a resistor. When you look at both as Laplace domain, as differential equations, they look the same. Interestingly, I start to see more and more patterns because as mechanical engineer, I did a bit of hydraulics. The Bernoulli's equations and the Kirchhoff's law and how the electrons flow and the water flow, they are all started to show similar patterns once you start to abstract. And that actually got me quite strongly connected with electrical, electronic, and mechanical systems. And I was fortunate to receive a Cambridge Commonwealth Scholarship to read my PhD at University of Cambridge, England. There I started working with a robot trying to control it. But soon we found we need to sense the world, and I diverted from the robotics more into computer vision and worked on a team where we developed a robot for physically handicapped people. This is 83, long time ago. Then from there, I moved to Australia. And I started to look at what I can do with computer vision, but in Australia, there were not that many opportunities for computer vision at the time. But there was a big interest in video coding, MPEG, JPEG, etc., if you know what I'm talking about. Then I got the thought, in computer vision, what I did was to take a three-dimensional image of a three-dimensional world and create a model. In computer graphics, we take a three-dimensional model of the world in the computer and create an image. So I asked the question, can we combine the two? And I found, yes, we can do some interesting image video compression algorithms using this technique. And by that time, I was working in Australia at UTS. And 2 students actually completed their PhDs in image compression and video compression along this line of thinking. And with video compression, I started to ask, what can I do next? And got interested in multimedia, hypermedia, and started talking and writing about it. With that, I ended up being in the editorial board of IEEE Multimedia for 8 years. And there I asked the question, okay, now we have all these videos and things. What can we do next? And start the growth of web. And show the potential for very large systems, because web is also a sort of a software system, but with the standard protocols between the server and the browser. And coming from engineering background, we started to promote web engineering. You will find in 2001, there are 2 special issues of IEEE Multimedia, where we promoted the idea of web engineering, which has now grown into a discipline on its own with its own conferences, etc. Having got that, then I asked, okay, now we have this web and wonderful things. How can we make it into something more useful for people? And then started looking at e-transformation, how the organizations can make use of this technology. And doing so, I came across a very interesting challenge, which you all also know very well, which we call wicked problem. We cannot get correct specifications for software. Things keep evolving. And what we did, what did we do? In waterfall method, etc., in the old methods, we try to write the specifications in a language we understand and try to ask a customer to sign. They don't understand very often. What we produce and what customer wants don't match. So I started looking at those because the businesses, when we start to work, their requirements keep changing, and came into this area of design for evolution and meta design. And it's in bold because I'll expand it a bit more in my next few slides. Having got that, I started looking at what else we can do to humanity. And then found food is going to be a major challenge. We can delay buying a shirt, a car, or something else. But if you are hungry, you need food. The world population is growing. Climate change is happening. What can we do in the food sector? And from that, we started looking at digital agriculture and found the current solutions still is not addressing the issues. And that is why I started looking at digital agri-food ecosystems. And as mentioned earlier in the introduction, I got the Australian Computer Society Digital Disruptor Gold Award for that early work in 2016, which has evolved a lot. And going beyond that, I think coming back to the main thing is how do you break the silos? Because the reality is everything is connected to everything. Especially with food, I need to work with agronomists, farmers, the supply chain people, and so many other people, the banks, the microfinance. How do you create systems? And brought in the systems thinking. And then we also have these major problems to solve, which is being characterized as sustainable development goals. And that brings me back to my question of how can we, as software engineers, what can we do to address these challenges? So I'll give some examples, and I will leave it up to you all to deliberate and think what you want to do, and also any opportunities for collaboration if this work is interesting. I'm very open for collaboration. So with that, if we look at design for the evolution and meta design, if we take a business organization, they have all sorts of requirements. So to meet some requirement, they will come up with a concept of having a system. A simple example could be a leave processing system. Then what we do as software engineers, we develop a system for leave processing. And we introduce it back to the organization. Now, business organization has an information system. Now think conceptually. The moment you do this, this is not the same system where you took the requirements. The people have evolved. They think of other possibilities, and they will ask for more things. The way people think, their needs will evolve as soon as you introduce, because it's a different environment. So we have to be in this loop continuously. So how do you solve this problem? And here's an example. Take off two systems, leave processing system and a purchase approval system, which are pretty common, very basic systems. And if you look at the two, in one, we have a leave form to fill. Other one, we have a purchase approval form to be filled, a form to be filled. Then it follows a leave approval procedure. We have a purchase approval procedure, which is a workflow. There are roles and actors who will apply, authorize, check. There are roles and actors. There are reports for the management, and there are reports for the management. So typically, what we do is we develop a system for this, and we develop another system for this. Now, what if instead of developing two systems, we develop one system, a meta system? What we need an object builder, which will create the leave form or the purchase form, interface renderer, a workflow engine which will schedule the forms, and an access control to give access to different use cases for the people. Then, if we have this, we can construct this and this by setting parameters in this meta level application. So in other words, a web application or software application has a set of aspects, and those aspects can be converted into models and attributes. Once we create the models, by having different attributes, we can generate different applications. Now, this particular one we took further, and we created a framework called CBEADS. And again, that name evolved over the time just to give you a flavor of it. Initial thought was component-based e-application development shell as I was working with businesses. Then it became component-based e-application deployment shell because we found we can also deploy, not only develop in the same framework. Then component-based e-application development system, because there was a methodology that evolved around it. And then we even went further through another PhD student where he came up with a user interface graphical via concept-based evolving application development systems. But in all these names, we managed to keep these words CBEADS. So we call this the CBEADS system. And we extensively use this now to quickly develop applications. And the main thing is it has the menus and it has the use cases. But one use case is we can create a function or a use case within the system. So in the runtime system, we can keep adding use cases and we can create data models within the system. By just modifying it and having another menu, we have now an evolving system which can be easily modified, which has given us tremendous ability to quickly do a system, check it, deploy it, but not at production level. When you go to production, there's too much overhead and the code efficiency is low. But to validate an idea, concept, and even to do MVP. So basically, with the meta design concept, we can have application development time where meta design interface, we develop it, it gets deployed in the same server, and we have the runtime interface. Obviously, there are certain challenges if we modify the database when there's data, we have to put certain restrictions on what can be deleted or soft delete. But all that has been done, and we have this platform which we found very useful. In fact, here is one of the offers I have. I was very keen to make this publicly available. We tried to do a GitHub and make a public repository and document. Never got around to complete it. And this is actually fairly old and done with Code Igniter. And ORM was, can't remember even the name. But we have a more cruder version done in Laravel, etc. So as a community, if you want to explore this, I'm very happy to organize a session to tell what we have done and open that code base to make this publicly available if there is interest from the community. But I still use it in the next part of what I'm going to say. This system to develop the concept testing, and also this acts as a sort of a specification tool now for the other developers. But I'm still involved in developing using this system. Then another area I want to talk a little bit more on the question of how to is we have to solve major problems. And as I said earlier, we went into digital agriculture. And though despite all the advances, the reality is still there's so much food waste, so many people go hungry. And the question is, are we doing enough? Though there are all sorts of advertisements, IoT, etc., have we understood the depth of this problem and do we have a good solution? And in the years of research, what we found was everything is connected to everything. Farmer needs inputs, knowledge, the money. There's no point helping farmer to get a higher harvest if they can't sell it. It's waste. There's no point giving knowledge to the farmers if they can't get the inputs, fertilizer, etc. on time. There's no point even making fertilizer available if farmer has no money to pay. So here it actually boils down to, at a root cause level, a coordination failure. And we have identified that it happens at 3 levels. One is the knowledge level. Farmers don't get the right knowledge at the right time. Other 2 levels are the material level. They don't get the inputs or the right quantities at the right time, which is a flow of material. And the harvest linking to the market is also not happening efficiently. And the 3rd level is the finance. They need the money to buy inputs, and then when they get the money, when they sell, they can pay off for the loans, etc. So we need to look at here how to coordinate the 3 flows: the knowledge flow, the material flow, and the information flow. So we started looking at this problem, and we have modeled the overall flow patterns. And now we have systems deployed where we work with research institutions, and we develop ontological knowledge base. And I think the person who developed this is today here, and very happy to see Professor Indika. When she was doing her PhD, she developed this, and today she is in this forum. And I think one of her students is coming over now to work with this area more with us. So we provide that knowledge, and we give it in a way to empower farmers. Another PhD happened, how to understand how we can develop mobile applications to empower people, mainly farmers. And then with the information we get, we can generate market intelligence that can be used to coordinate the different flows of buyers, logistic input suppliers, commodity market, financial services. Now we have got enough data in here where we are now moving into looking at AI, machine learning, and data science to discover new knowledge about our agricultural activities. So as I said, in each of these branch was a PhD. So that's the level, but still I was involved in coding, doing the data models in most of these. And I still do coding, that's my hobby. So I can be claim that I'm doing research and I'm doing software engineering as well. But we have done there's a 7th PhD started now on looking at the whole thing as economics. So here we have to work with software engineers, the agronomist, the entomologist, then farmers, buyers, sellers, logistics suppliers. But the thing is, you can see there is a system once you start to model how the information flows. Because the key is, we as software engineers, we can modify or enhance the flow of information. And all this coordination and knowledge exchanges happen as information flows. This is where I see we as software engineers are very special, and we are extensively needed to solve the problems we are facing. And then I'm at as you know, I'm a professor of information technology at the Western Sydney University. And our university was ranked world #1 in 2022, as well as now 2023, as the university that contributes most to achieving SDGs, Sustainable Development Goals. It's the Times Higher Education ranking, and we are very active in contributing to Sustainable Development Goals through our research, teaching, etc. So with all the research, the university helped me to start a company, startup Widya, mainly to create a better life for smallholder farmers. This is where the social part comes in. So the technology, career papers, PhDs, supervisions, and now creating an impact. And how we bring our research to bring that social part. And through Widya, now we have developed this full complete platform. We start with knowledge partners with the agriculture universities. So you can see we work with agronomists or the agriculture people. We digitize the knowledge. We convert it into actionable information through our platforms now. And that is being then presented to the farmers as actionable information. They can act. And this transformation happened through ontological knowledge bases. Again, that came from Professor Indika's PhD work. And the farmer actions then come back to the platform. When doing so, we capture 3 key variables: name of the crop they are growing, size of the land, and when they are planting. Moment we know this, we can generate crop calendars based on the planted date and the crop. But also we can generate a lot of aggregated data. How much input required, how much water is required, what is the predicted harvest. So the input requirements we can provide to water authorities. We had a big project in India doing that. The aggregated input requirements we can provide to input suppliers. And also the aggregated harvest coming from a community can be presented to the buyers. Now between farmers and buyers, now we can aggregate and get the benefit to farmers on the economies of scale. And we have developed aggregated online commodity platforms, market platforms for contracts to get established on blockchain using smart contracts, which was another PhD project, how it was done, the trust, etc. And once the contracts are established, the water will be distributed, the inputs will be provided, farmers can grow, harvest will be delivered to the buyers at this agreed period. Buyers will make the payments based on smart contracts. Some money will go to the farmers, some will go to the input suppliers, some will go for the water, some will go to the knowledge partners. So we can create a complete flow, coordinate the knowledge flow, the material flow, and the money flow. So this technology we have developed, it's running on data centers, all containerized, and in Singapore and in Bangalore in India to cater for farmers in India and Sri Lanka. That's where we mainly have deployed these systems. The top level is very much in a very robust way. Some of the bottom levels are still in research or proof of concept stages. And on that back end, we can develop various mobile apps very fast to connect and solve problems. So coming back, what I have shown you is by thinking and looking at the information flows and coordinating, we were able to connect all these people and link that to achieving 3 of the sustainable development goals: no poverty, zero hunger, good health and well-being. So you can see that there's a career, there's technology to be developed, we can create social impact, as well as we can be happy we have contributed to the humanity. Now to come back to my starting point and to conclude this brief idea presentation, I would like you all to reflect on how we capture knowledge. And there's 3 medium we can capture knowledge, or that we have. One is the DNA, which is and in fact, the basic ideas were in ACM communication going back about 15-20 years. I couldn't find the exact volume, but then I modified it to suit this presentation. So it is in the DNA, the knowledge is persistent, but updates slowly. We know it's evolution. And it's an unintentional process. We cannot control the nature. It's a natural process. But then through that DNA process, we become humans and animals, and we get a brain. And in the brain, it's volatile because we can forget, but we can quickly change. We can keep learning. and we can intentionally decide what to learn, what not to learn. Then if you think of it, we have developed machine tools. And these machine tools enhance our productivity tremendously, whether it's the electric saw, even a computer, all that hardware. But if you think of it, in that, knowledge of many, many people have been captured to increase the productivity, and someone else can make use of that knowledge on a daily basis. And the other medium to capture knowledge are the books. This is persistent once you write, but very slow to update because we are moving away from books and more to blogs and things which are much faster. But also this is intentional. But the final way and most powerful way is software, which is persistent, quick to update, and intentional. And we go into now machine learning, AI, ChatGPT, all that. And to do any action, we need knowledge. And as software engineers and as researchers, we have the ability to capture the knowledge of all sorts of people and create the information flows I mentioned, which can help in enhancing our careers and get publications, more research. We can put that into meaningful projects, as I showed you with agriculture, etc., and to create an impact, and which will then benefit everyone and create a sustainable future. So that sort of answers, or that's a one answer, how we can break the silos, because we can connect the people through information flows and use software to capture knowledge. So with that, I will conclude my quick talk.
Thank you, Professor Ginige. It was very inspiring, and coming from India, this topic of agriculture feels very close to home because India is very much dependent on agriculture as an economy. And I could also remember many incidents about the stories of farmers and how they get affected in the part of India that I grew up in. I'm very inspired that such technology is being developed and used to solve such crucial societal problems. I would now like to open the floor to anyone who wants to ask questions. We can take a few minutes and then we need to move into the discussion session. Also, if you're unable to ask questions here, please feel free to drop your topics in the discussion session so that we can have extended discussions. There is also a poster being presented by Anusha, which Professor Ginige had highlighted. So you can also come over there and discuss. So yeah, open to anyone who has the question. If there are no more questions, we can move into the discussion sessions and we can. Oh, okay. So Rowland has a question. Rowland says, "Thank you for the lovely presentation. Could I ask what would you prioritize if you were given a funding of say $100,000, and what would you do with it?" Professor Ginige, this is a question for you.
So the question is, if I'm given 100,000, what I will do?
Yes.
Okay, with 100,000, I will create a lot more digital agri-food ecosystems for the farmers, because we have a small team. Certainly, we can strengthen the team, and like I see it as an investment into the future. And we are also now looking at decarbonization. One of the key things we are looking at is actually starting a small farm, research farm, to generate that knowledge So if there is that type of funding, it will only accelerate what we do as a team, because we are doing it to make an impact. So we're very different to that whole business thinking. Yes, we have is sustainable, but that money, we are looking at a way of sustaining the project, not sustaining the people. And all this work, whatever we do is public, is published, is for everybody to make use of it, contribute, do whatever. So basically, yes, there are major problems in the agriculture area, especially with some of the supply chain models, and certainly I will be creating more and more ecosystems for farmers. We have some running in Sri Lanka and India. We can accelerate very fast.
Okay, thanks, Professor Ginige. Darwin says a research farm sounds like another cool idea. Even I have not, I never come across the term research farm, so I would be very interested to learn more about what a research farm is. With that, I would like to end this keynote session, and we now move into the discussion sessions. So please feel free to drop new discussion topics if you can think of any. And thank you again, Professor Ginige, for this excellent presentation.